We've done work with linear functions. We've done work with quadratic functions. The standard quadratic function is f of x equals x squared. And remember, f of x is just the function notation that's equivalent to y. So saying you have the standard quadratic function f of x equals x squared is the same as saying you're dealing with the equation y equals x squared. Only we know because it's a function that it has that special situation where one value of x is only matched up with one value of y. We'll never have two values of y that are matched with one value of x. That's what it means to be a function. So the standard quadratic function, if we think about the graph of that function, it's a parabola, and if we wanted to get some points to plot on our graph, if x was 0, the y value, or the function's value, would be 0. If x was 1, 1 squared is 1, so the y value, the function value, would be 1. And that would also be true if x was negative 1, because the square of negative 1 is also 1. So if x is negative 1, the function's value is also 1. If x is 2, 2 squared is 4, so the function's value is 4, or the y value is 4. And likewise, if x is negative 2, the square of negative 2 is 4, so the function's value is 4, the y value is 4 when x is negative 2. And this is the graph of the standard quadratic function. It's a parabola. It's a parabola that opens up. It's a parabola that's symmetric with respect to the y-axis. If we make some slight changes to that quadratic function, we can change the position of the parabola. One such change is if the coefficient of the squared term is negative. That simply makes each of these function values the opposite of what it is when we look at f of x equals x squared. What we end up with there is we end up with a parabola that opens down. Because each of these values, instead of the function value being 1, when we put 1 in for x, 1 squared is 1, but then the opposite of 1, or you can think of it as negative 1 multiplied times that x squared value, is going to give the function value then of negative 1. So when x is 1, the function's value down here at negative 1, and likewise when x is negative 1. The square of negative 1 would be positive 1. Positive 1 times negative 1, the function's value is down below the x-axis. And that would be true of each of those points. It's still symmetric with respect to the y-axis. The negative coefficient simply gave us a reflection, it's sometimes called. Well, we can make other changes. If we were to look at the graph of the quadratic function f of x equals x squared plus 2, we would find that what happens is the function values get increased by 2. If x is 0, 0 squared is 0, 0 plus 2 is 2. So now, when x is 0, rather than the function being 0, the function is up at 2. When x is 1, 1 squared is 1, 1 plus 2 is 3. So when x is 1, the function's value here is at 3. And likewise, that would be true if x is negative 1. The square of negative 1 is 1, 1 plus 2 is 3. And what we have is each of those points are simply moved up 2. So the function's graph looks like this. And if we were to subtract a value, it would simply move. Oh, what is this point called? What is the point called where the parabola turns? Well, that's called the vertex. So if we were to add 2, as we did here, it simply moves the vertex of the parabola up. If we were to subtract 3, it would have moved the vertex of the parabola down 3, so that it would have been here at 0, -3. So the graph of a quadratic function can be changed depending upon the coefficient of the squared term, if it's positive or negative. If it's positive, the parabola opens up, as we see here and here. If it's negative, the parabola opens down. We can adjust the vertical alignment of the vertex by adding or subtracting a constant from the squared term. Well, what happens if we introduce a first power term into our quadratic function? Well, that makes other changes to the parabola. It now is going to change the parabola not only vertically, but it's going to change the parabola horizontally. And in the next video, we will learn how to analyze the equation to help us know how to graph the parabola when those changes have occurred.